In the wilds of Chile, there are mountains that look like Oreos? These are Los Cuernos del Paine. Their unusual appearance draws thousands of visitors every year. With a thick light stripe between two dark layers, they out here looking like a snack. But besides looking cool, they actually have a lot to teach us about geology's star subject. That's right, it's the rock episode! Hit it, Dwayne! Hi, I'm Sage, and this is Crash Course Geology. Los Cuernos are amazing not just for their unique visual features, but because they showcase every part of the rock cycle. Listen, Dwayne, if you do that every time I say rock in this episode, we'll be here a while. Just tone it down a little bit, pal. The rock cycle is the process that recycles Earth's raw materials over time. The rock cycle makes it possible for any kind of rock to transform into another kind of rock. It's one of the forces that continuously freshen up Earth's surface. It's the reason why when you hold a rock in your hand, you're not holding something that's frozen in time forever. A rock's current identity isn't what it once was, or what it'll be in the future. But first, what really is a rock? Stonehenge, the Blarney Stone, Emma Stone. Since the dawn of time, rocks have held many meanings for many What? We don't have that much time. What am I supposed to do with these? As I was saying, in geology, the word rock has a specific meaning. A solid cluster of one or more minerals. Minerals, by the way, are solid crystals with a specific chemical composition formed by geological processes. Dwayne, one of us is going to have to change. Stubborn as a rock. I think a rock's kind of like dogs. You have your purebreds, like quartzite, which is mostly just the mineral quartz. Then you got your mutts, which are a mix of different minerals. Like Dwayne is granite, which is mostly quartz, feldspar, and mica, but can also have a lot of other minerals like hornblende, zircon, and magnetite. But even the rock mutts still fall into three basic types, classified by how they formed within the rock cycle. Sedimentary, like this super sandstone. Igneous, like this beautiful basalt. And metamorphic, like this nice. All three of these rock types were involved in the formation of Los Cuernos. Let's start at the bottom. Rock bottom, am I right? I think I just have to accept the puns at this point. This is sedimentary rock, which is created when bits of rock and minerals, called sediment, pile up and solidify into a solid mass. About 90 million years ago, before these mountains were mountains, their oldest rocks formed from tiny grains of mud and sand at the bottom of an ancient sea. Over time, this sediment was buried and squeezed like a geological panini until it formed a solid mass. Like, imagine if all the stuff at the bottom of your lockers slowly fused together over the school year. Paper clips, clarinet reeds, emo sweaters, all combining into a single locker rock. It's sort of like that, but on a much longer timescale. The sedimentary rocks at Los Cuernos are clastic. They formed from bits of other rocks that broke off, drifted away, and got compacted deep underground over time. If you wanted to get fancy, and I always do, you've got to know that there's more than one way to make a sedimentary rock. And I've got examples of all of them in my pockets. It's cool rock time! All right, Dwayne, it's your time to shine. This is limestone. Get a load of that puppy. It's a sedimentary rock that forms biochemically, meaning from the shells and bones of once living organisms. Cool, right? This one, you know it, you love it, you eat it. It's rock salt. It's a sedimentary rock that forms chemically from dissolved minerals that separate from water. Finally, this lump of coal is a sedimentary rock that forms organically from the compressed tissues of once living things. Can you believe this rock is made of leaf goo? How is our planet a real place? Let's turn it over to igneous rock, by far the most common rock type on Earth's surface. What's that, Dwayne? Sure, I guess classic rock is pretty common too. What? No, Blink-182 is not classic rock. I'm not going through this again with you. Sorry about that. Anyway, igneous rock forms when molten rock cools down and crystallizes into a solid. Geologists give molten rock different names depending on where it's hanging out. Magma is when it's underground, and lava is when it's above ground. Remember that thick light stripe on Los Cuernos? We can thank igneous rock for that. Around 12.5 million years ago, 3 pulses of magma pumped out of Earth's depths and slid in between the sedimentary rock layers that now make up much of the mountain. As the magma cooled over time, it formed a special type of igneous formation called a laccolith. It's giving belted Galloway cattle. Look at those spicy little guys. The igneous rock at Los Cuernos is intrusive. That means it formed from magma that rose up and cooled very slowly inside other rocks below Earth's surface. It intruded, if you will. But some igneous rocks, like basalt and this pumice here, form in a way that's extrusive. They're created when magma exits up to the Earth's surface, becoming lava, where it cools and hardens into rock. Our last stop on the tour of Los Cuernos is Metamorphic Rock, which forms when intense temperature, pressure, hot fluids, or a combo of these causes one kind of rock to transform into a different kind of rock. In other words, a metamorphosis happens, like a beautiful rock butterfly, a rockafly, a butter rock. You get it. At Los Cuernos, when the magma intruded into the mountain, it oozed between layers of sedimentary rock. As it did so, the magma's heat baked the rock it touched, causing it to change identity. Those rocks became metamorphic. Sometimes metamorphic rock takes on a foliated or stripy appearance. Gneiss, like the one I have here, has visible streaks because intense pressure flattened and rearranged its mineral crystals into even bands. But at Los Cuernos, the metamorphic rocks are non-foliated. That's because the rocks weren't squished by extreme pressure, only warped by intense heat. So the crystals never got pushed into stripes. Los Cuernos is so cool, but these mountains show us just one of the ways the rock cycle can play out. Many different factors can cause rocks to bop back and forth in the rock cycle, changing identities over time. Igneous rock can become sedimentary, then metamorphic, then back to igneous, or sedimentary again. Rocks go through more phases than me in middle school. Just look at Dwayne! His journey started underground millions of years ago when magma collected in a bleb under Earth's surface, slowly cooling to form our igneous buddy. Over many years, tectonic shifts pushed the land, and Dwayne, upward. As the land rose, other slow but mighty forces freed Dwayne from his rocky prison, weathering and erosion. You see, elements like water, wind, and ice act as hammers, sculpting rocks by breaking them down in a process called weathering. This can also happen through chemical processes. Like, rain is slightly acidic, so raindrops can spark chemical reactions as they land on rocks, transforming the minerals within them. And even living things can cause weathering. Trees weather rocks by creating cracks with their roots. People cause weathering by walking all over the same patch of rocks for years. Even tiny, unassuming lichen weather rocks by oozing acids from their root-like structures. We have got to change the game to rock, paper, scissors, wind, water, lichen. Weathering creates sediment, the stuff that eventually forms sedimentary rock. And then comes erosion, the process that washes away sediment and moves it somewhere else. Those two processes explain how Dwayne broke off from his home cliff and tumbled down to where I was hiking when I was like, hey, cool rock! And the rest is history. So yeah, nothing stays the same forever. The rock cycle is happening all around us, all the time. When you pick up a rock, you're touching something that's part of the same cycle that formed the Rainbow Mountains in China, the Giant's Causeway in Northern Ireland, and the Wave in Arizona, which honestly looks like something out of a Dr. Seuss book. No matter where you live, the rock cycle shapes the land around you. Understanding how rocks form and transform can give you a whole new perspective on the planet we all call home. Next time, we're taking a magnifying glass to gems. See you then. All right, Dwayne, let's go. Rock, paper, scissors, wind, water, lichen. Oh wait, you don't have hands. Thanks for watching this episode of Crash Course Geology, which was filmed at our studio in Indianapolis, Indiana. Made with the help of all these super cool people. If you want to help keep Crash Course free, for everyone, forever, you can join our community on Patreon.